Good morning. Today I'm going to teach you about variation models. So I need you to go take out your notes. So if you need to pause this video, you need some paper or your notebook. So over the next 2 weeks, we'll be taking notes together and doing some practice. And I'll be available to help you between 8:30 and 1:30 each day. All right, so here we go. I already wrote out notes, but I'm going to go through it a little at a time. And like I said, if I'm going too fast, pause it and rewind it and come back. All right, so today is St. Patrick's Day. And I'm sorry that I can't see you today. So we're going to learn about 3 variation models: direct, inverse, and joint. So first I want you to write this direct variation model. It's y equals a times x, and the a cannot equal 0. A is the constant of variation, and you learned this in Algebra 1 because this is like slope-intercept form. And we read that as y varies directly with x. Again, if I go too fast, pause it, rewind, and come back. The next model is inverse variation. That's y equals a divided by x. Again, the a cannot equal 0. We read that as y varies inversely with x. The next is the joint variation model. So this is very much like direct variation, except there's more than one variable being multiplied by the constant. So I have z equals a times x times y, and we read that as z varies jointly with x and y. I have another one, because it doesn't always have to be that way. I have p equals a times q times r times s, and we read that as p varies jointly with q, r, and s. Okay, so I'm going to give you some equations, and then you are supposed to determine if it's direct, inverse, or neither. So I'll try to hold this still, I apologize. So the given, I have 3 examples: xy equals 7, y equals x plus 3, and y divided by 4 equals x. So to determine which of those variation models it is, you should first rewrite it as y equals. So in example A, all I did was divide by x and got y equals 7 over x, which is similar to the inverse variation. The second one, y equals x plus 3, none of those models have a plus or a minus in it, so that one is neither, and I didn't need to rewrite it. And that last one, y over 4 equals x. To solve for y, just multiply both sides by 4, and I get y equals 4x. And that's an example of direct. Again, just pause the video as needed so that you can write this down and reflect on it before going on. Okay. So this is the type of problem we're going to work on today with all 3 models. So the first is how to write a direct variation equation or model. So I give you that the variables x and y vary directly and y equals 4 when x equals 2. So you're supposed to do 2 things. First, you're supposed to write an equation that relates x and y. Secondly, once you've done that, you find y when x equals -1. So I have 4 steps in order to do this. So step 1, you need to write down the direct variation model. The problem said it varied directly, so you go back to your notes. Our direct variation model is y equals a times x. Step 2, you need to substitute that equation with y equals 4 and x equals 2 and solve for a. So I set that up, putting y in for 4 in for y and 2 in for x. So I divide by 2, and then I get a equals 2. Now that's not the answer, but that's your constant. So step 3 is to write that original direct variation model, but only putting a as 2. So that would look like that, y equals 2x. So this is the equation that relates x and y. So you need that. So that's the first part where it says write an equation that relates x and y. And then the second part, which is step 4, is to find y when x equals -1. So taking that equation you just wrote, plug in the -1. 2 times -1 is -2. So again, please pause the video and rewind to where you need to so that you get this all down. So